You got this? Okay, so what we're looking at here, we're going to understand how electric motors work, and we're going to start by just looking at what happens if we get an electric current, like inside a wire, remembering that the electric current comes out of the red end of the power pack and it goes around through the wire this way and around to the black end. What happens if we put that wire inside a magnetic field and then turn on the current? The question is, what's going to happen to that wire that sits inside that magnetic field? And hopefully, can you see that as I connect it? Do you see what happens? You see it gets pushed out a little bit? See it moving? See it move? Look, if we turn this around the other way, check this out. Goes down instead. So we can't, it's not pulling that hard, but it's pulling hard enough to move a piece of wire. And so what we're learning is that, if we get electric current going through a magnetic field, that's going to make the wire move. And the rule that we've got for working out which direction the force is, it's called the right hand slap rule. And so we take our right hand and we make our thumb go in the direction of the electric current. So it's coming out of the red end along the wire. So the thumb is in the direction of the electric current. Your fingers are in the direction of the magnetic field. So this is the north pole, this is the south pole, and so the magnetic field's going from north to south. And the slap, if you've ever slapped anyone, you'll know that you always do it with this part of your hand, the palm of your hand, and so the slap is the direction of the force, right? So right hand slap rule. Thumb is current, fingers are field, slap is the force. And things that force depends on, we can make that force bigger by having a bigger electric current, by having more wire, and one of the tricks for having more wire is to get the same wire and just put it through the same magnetic field twice. So it's like when you're making a motor, if you've got like lots of coils of wire, that's just making the current go through the same magnetic field lots of times, and so it kind of multiplies up, like every time it goes through the field it makes the same force again. And the other thing is having a stronger magnet. So this is our 3D model. This is our right hand. The thumb is the current, the fingers are the field, and the slap is the force. And the reason we use the right hand is it gives us three different things that are all at right angles to each other. Like we've got the thumb going that way, at right angles to the fingers, and then the thumb and the fingers are both at right angles to the slap. So we've got three different things, all at right angles to each other. When we're trying to diagram this thing up, we've got magnetic field, and because we have to have stuff that goes into the board and out of the board, we have to invent new arrows that go into the board and out of the board. And it's like a game of darts, like when you throw a dart and it sticks into the board, you see the X of the dart. And so that means something going into the board, and same as darts, if someone throws a dart at you, all you see is the dot of the dart coming towards you. So if we're drawing something coming out of the board, we just do dots instead of X's. And so on this one, the fingers are the field going into the board, the thumb is the electric current going along, and so we can see that our slap would be upwards. And the way we can calculate the size of that force, we've got an equation. It's force is magnetic field strength times by the amount of current times by the length of wire. So force measured in newtons. Who remembers what magnetic field strength is measured as? Tesla. You know, you've heard of Tesla, right? Yes. Tesla, and the car's named after a really famous scientist, Tesla, Nikola Tesla. He was Croatian. And electric current in amps and length of wire in the field just measured in meters. And if you just times those things together, you calculate how much the force is. So it's really like easy.